Hello and welcome to operation of DSC. In front of us on the left we have our instrument. It is a TA Instruments brand Q100 model DSC. The DSCs come with many different options for cooling accessories, and we have on ours, down out of sight, a RCS 90, which allows us to go down to minus 90 degrees Celsius. Our upper temperature is 450 degrees Celsius. Um, in front of us, besides the instrument, we have our pan press over here, which I will demonstrate later. We have a balance so that we can mass out our samples precisely. And then we're going to use basic things such as tweezers, razor blade to cut samples up, and then the rest of it's going to be handled by the instrument. Today we're going to run a couple samples of PET, which is a very common polymer, polyethylene terephthalate. It's used in tons of different applications, and you will probably recognize it if you look at many different, especially food containers, use PET a lot. So I'm going to go over real quickly the steps that we're going to take to run the sample, and then we can go into more detail for each step. So the first thing to do will be to mass out our samples. Then we are going to place them in the pans and press them if needed. Then we will load them into the auto sampler. The auto sampler is here, so this is the carousel that holds up to 50 different samples and up to 5 different reference pans. The auto sampler arm is right here. It picks up the pans and loads them into the furnace, which is over here. Now if I open this lid, you'll be able to see inside. And the pans are placed on those two little pegs inside. And then they will be heated and cooled according to our program that we designate. So the first thing we're going to go over is weighing out and encapsulating our samples in the pans, and then we will go over how to operate the instrument. For the sample preparation, I have gone ahead and weighed out our two samples in advance because that would just be kind of boring to watch me use a balance. But the two samples that we're running are the PET as is, which I'm going to put a picture in because this will be hard to see. But the as is just an opaque whitish, has that appearance, and then the second one is a quenched version. The quenched version we have melted on a hot plate, and then we have cooled down very rapidly such that the polymer chains are locked into whatever state they were in when they were melted. So the quenched one, and you should be able to see this based on the data, the quenched one should be more amorphous than the as-is one. And the data will show us just how much that is. As a reminder also, we need a reference pan for each run, and the reference pan will be an empty exact version of our sample pan. We use two different types of pans. We use hermetic pans, and they're aluminum, and we use standard pans, which are also aluminum. The standard pans are just to hold the sample. The hermetic pans will seal the sample from the environment. So it hermetically seals, which means that nothing should be able to get in or out if you've sealed it properly, which is what we're going to do now. So even though we don't need hermetic pans for this process, it's good to know how the press works. So for the press, we have our pan and our lid that we're going to put into the press. So again, there will be a picture here so you can see this better. But the pan has the raised edges, and you set it in the press. And you can put the lid on before you put it in the press. That's entirely up to you. And then we need to use this Hermetic Dye Tool. So the dye tool has two sides. One of them is beveled, as you can see here in the glare, and the other side is just flat. So we first input the beveled side, and there's this little pin that sticks down. There we go, contrast. So the little pin comes down and is the same size as the hole in our die. So first we're going to do the beveled side down. That's going to take the pan edges and bend them in just a bit. And so all we do is then push down on the handle, which is super in front of the camera. And then you don't have to push very hard. This is very thin aluminum. And then again, the edges of the pan have been bent in just a bit. And so then the next step would be to use the flat side to make sure that the edges of the pan are fully bent in. It is possible, because this is such thin aluminum, you don't want to press down very hard. It is possible to break the seal by thinning out the aluminum too much. So there we have our first crimped sample. And it is recommended to immediately put this into the auto sampler, because once the pans are all crimped, they all look identical and you can't tell what's what if you get them mixed up. So definitely take advantage of that little nugget of wisdom there. Also make sure you do write down your masses or input them into the software as you measure those masses, because the software needs that, and I'll explain that when we get there. So I'm just going to crimp this second pan fairly quickly. So first beveled side down and press, and then we flip the die and do the flat side down and finish. And pan number 2. So we already happen to have a reference made, because we don't have that many different pan types. So we're not going to make a third one right now. But it is pretty straightforward to do that. You would just throw in an empty pan and crimp it. Next, we're going to go over the software, and we'll be able to watch one of the pans load as we start the first run. So you'll at least get to see the whole mechanism moving around. To connect to the instrument, we use the TA Instrument Explorer. So if you've watched any other videos relating to TA Instruments brand equipment, you may find this next section familiar, but there are definitely differences if it wasn't also a DSC. So we use the TA Instrument Explorer, and here we have the Q100 that says it's available to connect, indicated by no status messages around the little icon of the instrument. So we will double click on that, and it will connect and open up the window, which I will maximize as soon as it loads. And then this error message is going to pop up. It's normal and it doesn't hurt anything, so we're just going to hit OK and ignore it. A little layout about the software. So on the left side, we have our sequence of runs. So it looks like the last user ran 18 runs. These little red check marks indicate that the runs have completed, and the software will not attempt to rerun anything with a check mark. So if you added runs after this, it would ignore all the check marks and run the ones that you have added. Typically what we want to do is just make a new sequence, and it'll clear all these old runs and just leave us with one run. So we're going to hit this new page button on the top left, and we will be left with one run. One of the first things you do want to do when you open the software, though, is turn on the chiller. So the chiller by default is off, the RCS 90 that I mentioned earlier. and it needs time to actually circulate the coolant and get it cold. So we want to start that sooner rather than later. The chiller needs to be on regardless of what temperature you're going to. So even if you're not cooling below room temp and you're just going to be doing a heat, it still needs to be on as it protects some components inside the system during heating runs as well. To turn it on, we're just going to go to the control drop-down menu, which is where you can open and close the lid, as well as mess with the auto sampler. But mainly we use it to turn the event on. So they use the term event because of all the different attachments you could have. They don't want to call it the chiller because there's also other things that aren't chillers that you could attach. So it's a generic term for the external event that will be activated. So we're going to turn that on. And if you were right here, you would have heard a little click, and it sounds like a refrigerator running because it is a compressor similar to a refrigerator, although this one goes quite a bit colder. So back to the software layout. For each run that you have listed on the left, which currently we only have one, the center section here is unique and contains all the parameters for that run. On the right side, this is all the current running info. So the top part has the instrument readout, just what live signals you can read from the instrument. This middle section on the right shows the running segments, which currently are just listed as the last run that was completed. And then down on the bottom here, we will have the live readout of our data. Just note that the y-axis on the live readout is not normalized to the mass of our sample yet because it hasn't actually captured the data, so it doesn't normalize it until then. So for our first run, we're going to set up its parameters. So the summary tab will have the summary of the run. So the procedure summary, which we will ignore this and mess with that in the procedure tab. The sample name, we're going to change that to PET as is. Our pan type will change from aluminum to aluminum hermetic. There are tons of different pan types that we don't use just because we don't need them and they're kind of specialized applications. But their offerings are quite varied and can be useful in a lot of different situations. So we're going to choose our aluminum hermetic pans. The mass I measured for the as-is sample was 3.00 milligrams. And we've placed that into pan position 1 in the auto sampler carousel. And the reference pan for the standard hermetic seal is reference pan 2. You can use the same reference pan for as many runs as you want. So you don't have to throw that out and use a brand new one every time. And then we're going to choose where our file saves. So this part's easy to miss the couple times you use it because the first couple times because it's the same gray as the background here. So we're going to hit the browse button and it's going to open up a file browser. A very important thing about using the Q series TA instruments, so anything with a Q in front of the number, is that you must save it within the TA folder. So up here it shows the TA folder. It should have linked there already when you opened the file browser, but you need to make sure that you don't try and save to a flash drive or like the desktop or anything because the software was not given permission to write there. And there's no way to circumvent that. We've tried. So you must save it within the TA folder. So you would designate it based on if it's for class or research. And then within that, you would choose the research group that you're dealing with. So for classes, you would choose the class number. So I'm going to go into research and just throw it in the AMSEC folder. And we're going to give it the same name as our the sample name, the file name and the sample name we're going to make the same. So don't give it a file extension because the software will auto assign one and it won't overwrite any files ever. So if you happen to have multiple files with the same name on accident, it won't overwrite them as long as you don't put in a file extension. So now we can see that it's in the AMSEC folder like I told it to, but we can't really see the name. If you highlight over, it'll show you the rest of this. So you can see that it is named correctly. So that's the summary of our run one. Now we're going to go to the procedure. There are a number of different templates for procedures that are included. You can also do custom runs if you want to customize that yourself. But the templates would be the ones that you'd typically use. And the most common test is the one that we're going to do, is called a heat, cool, heat. And it does exactly what it says it does. So we are going to heat the sample up, we're going to cool it back down, and then we're going to heat it up again. Now, as I mentioned, we can go down to -90 degrees Celsius, but our starting temperature does not need to be below room temperature for this specific material. So you have to have a little bit of prior knowledge about your material before coming in and setting up the DSC. For one, we don't need to waste time. If the sample is already fully solidified at room temperature, we don't need to cool it. However, if the sample is liquid or is past its glass transition, then we would need to cool it. So you need to maybe look up some values, or if you can't find any information, then you'll just have to do a run to see. That takes a long time with a broad temperature range to see what range you actually need to confine it to for further runs. One thing you definitely need to do if you don't have any information about your sample is you need to run a TGA, and the TGA will give us our degradation temperature, because we don't want to degrade samples inside the furnace because it dirties it up, and the furnace is very sensitive to any changes, including stuff being deposited on the furnace because you degraded samples inside. Degrading samples inside hermetically sealed pans can also cause them to pop open if they're pressurized too much by the gases released. And if that happens and sample gets all over the furnace, then we could have a significant downtime as we have to clean it out and recalibrate the instrument, which takes most of a full day. So we've ran PET before. It's easy to Google this and get information on its temperature ranges that it can handle. So for our start temperature, we're going to start at 25 degrees, so around room temp. For heating rates, typically heating rates we start with are 10 or 20 degrees C a minute. You only want to go slower if you're trying to separate out two transitions that happen near each other. So we're going to set our heating rate at 20. That's very normal. That's what we typically do. We're going to set our upper temperature at 275 because PET melts around 260, 250-ish. And then we're going to cool at the same rate and go back to 25 degrees. So what this tells us is we're going to start at 25. We're going to heat at 20 C a minute to 275. We're going to cool at 20 C a minute back down to 25. And then what it doesn't show, because it uses the same parameters for the second heat, is heating again from 25 to 275 at 20 C a minute again. Whenever we've made changes to our run, the left side will gray out as it is right now. And then you simply need to apply or cancel those changes that you've made. So we're going to apply them. And then the left side will turn white again, which means that you're available to add or remove runs. Under the post test button here, we have an option to discard our pan. So usually these sample sizes are so small and people don't need to recover their samples. So usually we'll check this box and it will drop it in the little waste bin, which we will be able to see in the time lapse of the run. So I'm going to show you guys that run. And then under the notes tab, you can put in the operator name, which is helpful for future people who might need to know whose research notebook to look into if that's what you're doing this for. And then the mass flow control settings, you really don't want to mess with those because, again, with flux in and out of the cell for heat, changing the heat flow that's measured, all the calibrations we do are done at this gas flow, which means that if you change that gas flow and the calibrations aren't updated, then the heat flow measured will not be accurate. So back to the summary tab. It looks like this run would be ready to go. We have some changes to accept, which I think it was just changing the operator name. So we're going to hit apply. If we want to add our second run, which we do, we're going to hit the append button, which is down here next to where the apply button is. And the append button will copy whatever run you have selected. We only have one run, but some people have more than one run. And if you have multiple different styles of runs, you can choose which one you copy by selecting it and then hitting append. When we hit append, run 2 now shows up here. And everything for run 2 is identical to run 1, except that it changed the sample size to 0 and it incremented the pan for us. So the pan was pan 1 for run 1, and now it is pan 2 for run 2. So we're going to change the sample name to PET quenched. And then I'm going to input the sample size I measured, which was 3.21 milligrams. And then we're going to input the data file name as PET quenched in the same file location. One thing I haven't mentioned yet that I kind of forgot was for sample sizes, you want to keep it between 1 and 5 milligrams. And somewhere right in the middle is a good sweet spot. If you have too much sample, it'll take too long for it to equilibrate. So say it's going to melt really slowly if you have a giant chunk of sample. 5 milligrams might not seem like a giant chunk, but with how sensitive this instrument is, 5 milligrams is quite a bit. And so somewhere around 2 to 3-ish milligrams is usually pretty good. It does depend on what kind of sample it is. If it's a liquid, if it's a powder, if it's a solid chunk, you might need to play with this and check, redo the runs based on how your data looks. So our runs are ready. So this red arrow pointing to the right indicates that run 1 is going to be the first one that starts. And so all we're going to do is go up here and hit play to start the run. Now we're going to do a time lapse and watch the data collect for this run. It is going to take about 45 minutes, but we're going to make our time lapse go quite a bit faster than that because there's no reason to sit here and watch this for 45 minutes. I'm going to expand the window a little so that our data is a little easier to see, but otherwise just going to let this run. Now we'll watch the auto sampler load our first pan and reference. And so you can get an idea for how this mechanism works. So the auto sampler has 3 little tines on the arm that grab the pan, lift it up, and it will very gingerly set it down onto the peg. So that was the sample pan. And then it's going to now do the reference pan. You can kind of see it, the reference, because it wasn't so close to the edge of the carousel. And then the furnace will close and the run will begin. That's the little waste bin that I talked about. It just drops the pans in there and then they get emptied once in a while. Thanks for watching. Feel free to email me any questions at the email on the screen.